Hello students, welcome to the next lecture on the linear algebra. Today I will explain you how you can solve the problems related to the eigenvalue. Myself Dr. Harish. You can follow my YouTube channel where you can find the playlist of CSIR UGC NET, and you can see the various lectures related to the matrix, system of the linear equation, rank, numerical methods and many more available in this playlist. You must subscribe my YouTube channel so that you will get the notification when I uploaded my next video. Now remember always student, whenever you will see a question related to the matrix in your examination, that question you can solve either with the help of the eigenvalue or with the help of the rank of the matrix. These two lectures I have already explained you in our last lecture with the help of the 50 plus PY question series. Now in this lecture I will try to cover this portion, and in this video I will explain you 55 plus PY questions which I explain you with the help of the fully shortcut tricks. Fine. Now make sure you must watch these three lectures, that is a matrix, rank and the Jordan and diagonalizable form, before watching this lecture, so that you can learn the shortcut tricks in a very simple manner. Apart from that, you can see the complete PY question series with the help of the shortcut tricks which is available in my these videos. Now I am not summarizing, I am using in this lecture, I am using all those shortcut tricks which I explain in these three lectures. So you must watch and understand these lectures deeply, because I have using the same shortcut tricks that I explained in these three lectures to solve the problem in this today's lecture. If you are new to my YouTube video, you can scan and join my WhatsApp group for the discussion part. I hope you can subscribe my YouTube channel. Now the first tips, always remember that whenever you have a matrix, fine, how you can find the eigenvalue. Always first step come in your mind always is you can check the sum of the each row. Fine. If the sum of the each row is my k, same, then you can say k is one of the eigenvalue. Same for the column. If you find the sum of the each column is my k, then you can say k is my one of the eigenvalue. Always remember, whenever you will see the concept of the eigenvalue in the problem, start with this first step. Fine. Now look at this one. It's a 3 cross 3. Your target is to find the eigenvalue. So it's a 3 cross 3. Your target is to find the 3 eigenvalue. One eigenvalue is already given to you. Fine. Then how you can find the other two eigenvalues? First of all, we will see this concept. What is the row sum? 0. Row sum 0. Row sum 0. So that means 0 is one of the eigenvalue. Look at the column sum. This column sum will be my 48. This column sum will be my, it is not 48. So they are not same. So this property not satisfied. So 48 is not the eigenvalue. Now you have the two eigenvalue. Can you find the third eigenvalue? The sum of the eigenvalue will be, this is say my x is my trace of the matrix. So what is the trace of the matrix? 2. What is the third eigenvalue? 20 minus lambda is the right. You can see a very simple trick, you can solve this problem. Now A has a 4 cross 4. It has a 4 eigenvalues which is given as -1, +1, 2 and -2. The matrix B is defined as A4 minus plus 5i, where I is a 4 cross 3. Then which of the following statement is my correct? Again, because it's a matrix, you can find the eigenvalues of the B. If A has eigenvalue -1, what is the eigenvalue of this? So it's a +1 plus 5, that's a +1. I can substitute 1 in this case, again it's a +1. If I substitute 2, it's a 16, 4, 20 plus 5, again 1. If I substitute -2, then again 16, again -20 plus 5, it's my 1. So A has eigenvalue this, B has eigenvalue this. Then the determinant of A plus B. What is the eigenvalue of the A plus B? 0, 2, 3, -1. What is the determinant of this Determinant of the matrix is the product of the eigenvalue. So which of the following statement is correct? Yes, fine. Determinant of the B, product of the eigenvalues of the B, again 1, correct option. Trace of the A minus B, can you find the eigenvalue of the A minus B? It's a minus of 2, 0, 1, minus 3. If you find the trace of the eigenvalue means, trace of the matrix means sum of the eigenvalues. So it is a minus 4, which is non-zero. So this option is cancelled. Trace of the A plus B, these are the eigenvalues of the A plus B. What is the sum of the eigenvalue? It is 4. So yes, this is also the right answer. A, B and D are my correct answer of this problem. Look at this another one. Let lambda and mu are the eigens. Okay, there are the two eigenvalues. These are my distinct. I consider any two eigenvalues. That means I consider, you can say 1 and 0 if you want. Fine. 1, 0, 0, 0. This is the 2 cross 2 has the two distinct eigenvalue. Then A square has a distinct eigenvalue. That is not always true. If I consider the two eigenvalues as 1 and minus 1, what is the eigenvalue of the A square? It's a 1 and 1. Both are the same. This option is cancelled. I will check about the B option later on. Trace of the A raised to power n for every positive integer. If A has eigenvalue lambda and mu, what is the eigenvalue of A raised to power n? Fine. Then what is the trace of the A raised to power n? This is the sum of this eigenvalue. So yes, this is the correct option. A raised to power n is not scalar multiple of the identity for any positive integer n. That's very simple. I can simply choose this matrix. What is my A square? 1, 0, 0, 1. I can return this is 1 into I, but he said it is not alpha for any alpha, but I can say this option is also cancelled. Now look at the second option. Again, I have the eigenvalue 1 and minus 1. So what is the eigenvalue of the A cube? 1 minus 1. Let me check whether the RHS, and firstly I can simplify this. What is that? This is my, if I say this is A cube lambda square plus mu lambda plus mu square into A minus of this number. Fine. Now you can verify it. If you simply take lambda, or you can, if I take A has eigenvalue lambda, I can substitute this value as lambda. If you open them, lambda cube, lambda square mu, mu square lambda minus, you can see this number will be cancelled. So that is a lambda cube is a cube. So similarly mu is also satisfied. Yes, this option is also satisfied. So B and C are my correct answer of this problem. I hope you can like and comment on my video to support it. Based on your likes and comment, I will upload my next video which is related to the analytic function. If I got a good response from this video too, I will upload the next video on the lecture series on the complex analysis. Okay, let's start with this next question. A is my complex 3 cross 3 matrix such that A cube is my minus identity. This is given to you. Then A has 3 distinct eigenvalues. That is not true. If I simply choose this number, or you can say if I choose A is equal to minus I, it satisfies this property. Fine. What is the eigenvalues of this matrix? Eigenvalues are minus 1, minus 1, minus 1. They are not distinct. First option is cancelled. A is diagonalizable over C. Now once you are talking about the C, A cube is minus I. Can you find the eigenvalues of this? Lambda cube is equal to minus 1. It is minus 1 minus omega square. Now clearly say these are the distinct eigenvalues. So it means if they are the distinct eigenvalue, it means they are diagonal. B option is the correct matrix. So that means A is diagonalizable over the complex number C. A is triangular. So once A is diagonalizable, then we all know A is also the triangular. So yes, it is true, because I can write this matrix like of this manner. Fine. A is non-singular, that means we need to find the determinant. If A has eigenvalues this, what is the determinant of this matrix? This is -1, which is non-zero. So that means it is a non-singular, is also the correct option. So right answers are B, C and D are my right. Don't forget to like and comment on the video. P is a 2 cross 2 matrix such that P star of P is my identity. Then the eigenvalues of the P. Do you remember that? What is my shortcut tricks given to you in the problem of the rank? If you have these two matrices such that AB is equal to identity, can you find the rank of the A, rank of the B? Rank of the A is my number of the rows. Rank of the B, that is B is the column, number of the columns. So same for here. Can you find the rank of the P star? What is the P star? Is again 2 cross 2. Rank of the P is my 2. Fine. Remember that. That's why I'm asking you. You must watch about my previous 3 lectures, rank, matrix and the diagonalizable matrix. Then your target is to find the eigenvalues of the P. That's very simple. This is given to you. I can say P into P star is my 1. Fine. I can written this is P into P star is also 1. Fine. So if P has the eigenvalues lambda, then I can say this is my 1. That means, because it's a complex number, I can say it's a modulus here is 1. So that means modulus is my, so of modulus 1 is the reciprocal to each other. That is not always conjugate complex real, that is may or may not be true. So the right option is my D is the right answer. If A is my 5 cross 5 with a trace, so you need a 5 eigenvalues. Trace is 15. 2 and 3 are the eigenvalues with algebraic multiplicity are my 2. So algebraic multiplicity of the 2 is 2. Algebraic multiplicity of the 3 is my 2. What does it mean? 2 occurring 2 times, 3 occurring 3 times. Now can you find the fifth eigenvalue? The sum will be the 15, because trace is my 15. So what is the fifth eigenvalue? So 2 plus 2, 4 plus 6 plus x is my 15. This number is my 5. Then the determinant of the matrix, that's the product of them. So it's a 4 into 9 into 5. So that means 4 into 45. That is 180 is the right answer of this problem. You can see within the 10 to 15 seconds you can solve the problem. I again request you, don't forget to like and comment on my video. Subscribe my YouTube channel so that you will get the notification as well. A is invertible 4 cross 4 matrix. A is invertible, that means determinant is a non-zero. If determinant is a non-zero, that means 0 is not eigenvalue. Fine. Or if you think about the rank of the A will be number of the column vectors. Then rank of the A will be my 4. This, by using the concept of the rank, for every matrix, every vector B, Ax is equal to B has exactly one solution. That means unique solution. When it will be the unique solution? We all know we need a unique solution only when rank of the A must be the number of the column vectors. Column vector is my 4 and it is given to you. So that means yes, this is also true. Dimension of the null space. So I can use the rank nullity theorem. Rank plus nullity is the number of the column vectors. So 4. Rank is my 4. So can you find the nullity? Nullity is my 0. Fine. So dimension will be 0. So 0 is greater than equal to 1, not satisfied. 0 is the eigenvalue, not, because determinant is a non-zero. So 0 is not the eigenvalue. This option is also cancelled. A and B are the right answer. You can see that within a couple of seconds you can get your answer in a simple manner. Make sure you have to watch this video till the end. You will learn many shortcut tricks. Okay, A is my 2 cross 2 matrix. Alpha n and beta n denotes the two eigenvalues of, these are the eigenvalue of a raised to power n. So I can find the eigenvalues of the A. Fine. So how you can find the eigenvalues of the A? Minus trace of the matrix plus determinant of the matrix. So determinant is my minus 1. Fine. Remember, the rule is trace of the A matrix plus determinant of the matrix. Now can you find the eigenvalues of this? Minus b square plus 4ac over 2. So 1 plus minus root 5 over 2. Then what is the eigenvalues of the, what is the eigenvalue? One is the alpha, one is the beta. Because alpha is greater than beta, so I can choose alpha is this number and beta will be this number. Fine, because clearly say this number is my greater than. Fine. Then alpha raised to power n will be, this is the eigenvalues of A raised to power n, and beta raised to power n will be 1 minus of this number. Fine. Then beta n is negative if n is odd. Clearly say this number is my less than 0, because root 5 will be my 2.2 something. If you subtract 1 minus, it's a negative. So if n is my odd, then beta is will be, this will be odd if n is odd. Yes, this is the correct answer. Beta n is a positive if n is positive. So yes, because it is a even. So if I say n is even, then it is also positive number. Fine, this is also the correct option. Beta n approaches 0 as n approaches infinity. So what is the exact number of this? It's a 2.2 divided, so it's a 0.6, that is a less than 1. Fine, the absolute value of this is less than 1, and we all know r raised to power n, that is the GP series, will goes to the 0 if this value is less than 1. This value goes to the infinity if mod of r is greater than 1. Clearly say beta will be less than 0. Fine, or it's a 0.6. If you take the modulus, it's a less than 1. Yes, it goes to the 0. What is the alpha? It is 1 plus 2.2 divided by 2 is a 3.2, is a 1.6, that's a greater than 1. Once it's a greater than 1, it will go to the infinity. Yes, all these 4 options are my correct answer. Alpha A is a real symmetric matrix. If it's a real symmetric matrix, eigenvalues are my greater than equal to eigenvalues are my real. Fine. A does not have 0 eigenvalue. Can you think about any matrix? Matrix is not given, I can consider 2 cross 2. Can you think about any 2 cross 2 matrix, which symmetric matrix in which 0 is the eigenvalue? Yes, you can see this is a symmetric matrix. Fine, this is a real matrix. Fine, but 0 is the eigenvalue, but he said does not have eigenvalues. All the eigenvalues of the A are real. Yes, that's true. All the eigenvalues are my real. Real means it's a positive, it may be negative, or it may be 0, but it must have a real eigenvalue. If A inverse exists, then A inverse is real and symmetric. That's true, because A is my real. Fine, so A inverse is also real. A inverse is symmetric, A is symmetric, this is also symmetric. So yes, that's also true. A has one positive eigenvalue. Is it always true? Can you think about any of the 2 cross 2 in which there is no positive eigenvalue and the matrix is real and symmetric? -1, -2. It is a symmetric matrix. What are the eigenvalues? Eigenvalues are -1 and -2, but none of them is my positive eigenvalue. So B and C are my correct answer of the problem. Okay, A is my this matrix such that 6 A inverse is A cube, A square plus BA plus CI. What is the values of the A, B and C? You may think about that A is given to you, you can find the A square, and then you can find the A inverse and substitute in this case. No need of them. Make sure you are in the competition exam. What is the shortcut tricks is find the eigenvalue. How you can find the eigenvalue? Firstly, check whether the row sum 3 minus 1, they are not same. Check about the column sum 2 minus 2 1, so they are not same. Fine. Now how you can find the eigenvalues? Start with quickly of a minus lambda I is 0. So that means 1 minus lambda 0, minus of 2 1, minus 2, and minus 3 minus of this. So clearly say if you expand them, because minus of 2 it will be 0 minus 0, so the eigenvalues are these are the, if you expand them it will be 1 minus, minus of 2, minus of 3. Fine. So what is the eigenvalues of this? 1, minus 2, minus 3. Fine. Now you can substitute the answers at this. So A has the eigenvalue 1, minus 2, minus 3. Can you find the eigenvalues of the A inverse? 1, minus 1 over 2, minus 1 over 3. Now substitute here. Firstly I can take as a 1, A plus B plus C. Fine. Look at the option, A plus B plus C is 6. Cancel. Cancel. 6 satisfied. Look at the second eigenvalue, 2. A inverse is minus 1 over 2. A is equal to minus of 2. Square is 4A minus 2B plus C. Now we can check about that. 4A 16 minus 2 plus 1. Is it minus 3? No. This option cancel. Check about the fourth option. 4 minus 8 plus 1 minus 7 plus 1. Yes, minus 3 satisfied. So D is the only right answer of the problem. There is no need to apply the Cayley-Hamilton theorem, just about the eigens value. Again you can see the matrix is given to you. You can solve this problem with the help of the eigenvalue as well as the rank of the matrix. But now they are asking you about the eigenvalues. So first of all, what is the trace of the matrix? Trace is my minus 4. Look at that, the sum of the eigenvalues minus 4 satisfied. This is not satisfied. What is the eigenvalues of this? Minus 4 plus root 13, minus 4 plus minus root 13. So sum of them is a minus 4 satisfied. What is the sum of these eigenvalues? It's a plus root 7 and minus root 7. If you add them, it's a 0. So this option is also cancelled. Fine. Now the next option will be, you have to find the determinant. There is no need to apply the A minus lambda I. Firstly check whether the row sum, what is the row sum is? 4. Row sum is 4. Row sum is 4. So that means 4 is one of the eigen value. None of them is my 4. So the right option is C is my right answer of this problem. You can see that I can quickly discard the options from their given trace as well as my shortcut tricks, sum of the rows, or you can check about the column. Column is my 4, column is my 4, column is my 4. So 4 is one of the eigen value. So this option is discarded. Okay, I can take N is my 2. So A will be my 2 cross 2 matrix such that A square is equal to A. You know what is the A square is equal to A meanings? That is a idempotent matrix, or it is also called as projection matrix. Fine. Then so that's very simple. You can, this is A square is equal to A. Fine. Otherwise if you think about the eigenvalues, what is the eigenvalues of this? Eigenvalues are my 0 and 1. A is the diagonal, because the eigenvalues are my distinct. Fine. If eigenvalues are my distinct, they are my diagonal matrix, and if it is a diagonal matrix, the diagonal matrix will be the eigen value. Yes, this is also the correct option. Rank of the A. So look at that. What is the rank of this matrix? Because one eigenvalue is my 0, what does it mean? Determinant is my 0. If determinant will be 0, what is the rank of the matrix? Is less than equal to less than or equal to 1. But one eigenvalue is non-zero, so that means rank of the A is non-zero. Why? Because if rank of the A is 0, this implies A is 0, but that is not possible. So therefore rank of the matrix is my 1. If rank is my 1, what is the trace of the matrix? Sum of the eigenvalue, both is my 1. Now eigenvalue of the A is my 0 and 1. Can you find the eigenvalue of the I minus A? Is 1 minus 0. The trace is 1. So if rank is my 1, I minus A also has the rank 1. So yes, this option is also correct options. All are my right answer of this problem. Okay, A is my 4 cross 4 matrix. They are talking about the eigenvalue. So your target is to find the 4 eigenvalue. Dimension of the nullity. What is the dimension of this nullity? Dimension of the nullity means you will provide the geometric multiplicity. What is the geometric multiplicity of the eigenvalue 2, which is equal to the dimension? What is that? It's again the dimension. Geometric multiplicity of the eigenvalue 4 is my 1. Rank, it's a 4 cross 4. Rank is my 3, which is less than of the number of the column vector. What does it mean? That means determinant is my 0. So one eigenvalue is my 0. Fine. So if one eigenvalue is 0, geometric multiplicity of the 2 is my 2. So that means the eigenvalue 2 occurs 2 times. Geometric multiplicity of the 4 is my 1. So it is my 1. So 0, 2, 4 are the eigenvalue. That's fine. Determinant of A is my 0. That also fine. A is not diagonalizable. How you can check that? The one way is you can check the algebraic multiplicity of the eigenvalues must be same as of the eigenvalues of this. So clearly say algebraic multiplicity of the 4 is geometric multiplicity of the 4 because it has a unique number. Similarly, algebraic multiplicity of the 0 is same as geometric multiplicity of the 0. Fine. But how you can check about the algebraic multiplicity of the 2? You are unable to find because the matrix is not given to you. Again, how you can check about the diagonalizable? Again, as I told you in my previous matrix, if you find the sum of the geometric multiplicity, if this is equal to the number of the column vectors, then you can say this is my diagonalizable. So what is the geometric multiplicity of the 2? 2 plus what is the geometric multiplicity of the 4 is 1. What is the geometric multiplicity of the 0? I can found that geometric multiplicity of the 0 means dimension of the nullity of A minus 0i. Now rank is my 3. What is the nullity of the A? By the rank nullity theorem is 1. So that means it is my 1. So which is my 4, and 4 is my number of the column vector. Yes, this is a diagonal, but he said no. Trace is my 8. You can check about the trace. Yes, this is the 8. A, B, D are my right answer of this problem. Consider the matrix A, then eigenvalues. So first of all, it's a 3 cross 3. You need a 3 eigenvalues. A has eigenvalue 0 for some x. 0 is not the eigenvalue. Okay, fine. I can find the determinant. If determinant is a 0, what is the meaning? 0 is the eigenvalue. Fine. So firstly find the determinant. 1 plus x square. This is 26x minus 68 minus 7. 39x minus 32x plus 11. 51x minus 16x square is 0. Now there is no need to simplify this. Clearly say this has the coefficient of the x cube, this has the coefficient of the x square, coefficient of x plus constant is 0. Fine. Now clearly say this has the cubic equation. So once it's a cubic equation, it has must one real root. So what is the root of this? That is called as the eigenvalue. Fine. So that means this is 0 for some x. Definitely you will get some x from the R which will satisfy this equation. Why? Because 1 is the real root. 0 is not the eigenvalue. Wrong. A has eigenvalue 0 for all x. That's not true. If I simply choose x is my 1 or x is my 0, if I choose x is 0, what will be my A? 1 0 0, 7 0 17, 11 4 30. Clearly say that determinant is my non-zero. So for all is my wrong one. Otherwise you can substitute x is equal to 0 in this case. It is my 1 into minus 16. This is 0, this is 0, which is non-zero. Because of this for all, this option is cancelled. A is invertible for every. That's again the wrong, because in the first case we will get at least one real root. For every, that's why this option is cancelled. A is my right answer of the problem. Okay, look at this another one. A is my real symmetric matrix. That means eigenvalues are my real. Make sure it can be positive, it can be 0, or it can be negative. So A has eigenvalues lambda. B is equal to I plus, what is the eigenvalues of the B? 1 plus iota lambda, because eigenvalues of the complex number occur in the pair, so it is 1 minus iota lambda. B is invertible. That means determinant is a non-zero. This implies determinant is product of the eigenvalue. This is non-zero. Fine. So if and only if A is invertible, does it implies lambda is a non-zero? No, because it doesn't imply that lambda is a non-zero, but he said if and only if, this option is cancelled. Because if lambda is 0, that means A is invertible. A is not invertible. Fine. So this option is cancelled. All the eigenvalues of B are necessary real. Eigenvalues of B are my this, and since lambda is my real, it is not a complex number, so this eigenvalues of the B are always complex number. Fine. No, not always complex number, because if lambda is 0, then it is a real, but he said necessary real. This option is cancelled. B minus I. Can you find the eigenvalues of the B minus I? B has eigenvalue this. If I subtract the eigenvalues, then it will be is necessary invertible. What is the determinant of this? It is lambda square. Is it always 0? Is it always 0? No, because if I take any value of lambda which is greater than 0, then this is non-zero. So this option is also cancelled. B is necessary invertible. What is the determinant of the B? 1 plus lambda square. Clearly say which is non-zero for any value of the lambda. Fine. Even you may choose lambda is 0, but still it is a non-zero. There is no value of lambda satisfied this condition. So yes, D is my right answer of this problem. The trace of this matrix. It's a matrix, so you can solve this problem with the help of the matrix also. If I call this is my A, then your target is to find the A raised to power 20. What is the eigenvalues of the A? Clearly say it's a diagonal matrix. Eigenvalues of this. What is the eigenvalue of A raised to power 20? 2 raised to power 20, 2 raised to power 20, 3 raised to power 20. Then what is the trace of A raised to power 20? This number plus 2 raised to power 20 plus 3 raised to power 20. That means 2 into 2 raised to power 20 plus 3 raised to power 20. 2 raised to power 21, 3 raised to power 20 is the right answer. C is my correct answer of the problem. Don't forget to like and comment on my videos. It will help me to spot. I will upload very soon the next lectures on the PY questions on the complex analysis if I get a good response on this video. Okay. If M is the collection of all those 2 cross 2 matrix such that entries are my integers, eigenvalues are my in Q. Okay. Then M is empty. Why M is okay? clearly say if I choose any of the matrix 1 1 0 0, for example, all these entries are my integer. What are the eigenvalues? Eigenvalues are the 1 and 1, which are the part of the Q. Fine. So that means A belongs to the M. So M is my empty false option. Fine. Second option, M is the collection of all those elements A, B, C, D such that A, B, C, D is my Z. All the elements are in the Z. So how you can say that these are in the Z? Is it always? Yes, it is already given that M is the collection of all those elements such that A, B, C, D are in Z. So yes, that's true. A belongs to the M, then the eigenvalues of the A are in Z. Eigenvalues are in the Z. Okay. If I say lambda 1 and lambda 2 are the eigenvalues of the A, then determinant of A will be this number, trace of this eigenvalue is my this number. Now A, B, C, D are my integers, so definitely the determinant is also my integer, trace is also my integer. So once the sum of them is integer, product of them is integer, the roots will also be my integers. So yes, this option is also my correct option. A and B belongs to the M such that AB is equal to I. Okay, that's I already gave you the tips in my previous matrix lecture. What is the tips is, if A has integer entries such that determinant of A is my non-zero and AB is equal to I. This will happen if and only if determinant of A is my plus minus 1 only. Fine. If determinant of A is my plus minus 1 only, and if A has integer entries such that A is my invertible, then AB is equal to I happens only if and only if a determinant of A is plus minus 1. Now you can see A and B belongs to the M, so first property is satisfied. AB is equal to I if and only if determinant is my plus minus 1. Yes, it's a plus minus 1. This option is also the correct option. So the right answer is B, C and D are my right answer of this problem. Fine. Now no, just A, B, C, D are in integers. No, I think no, from this option is wrong. If I simply choose the matrix is my this number, fine, A, B, C, D, then M, all the eigenvalues are in the Q. What is the eigenvalues? 0. Is the 0 belongs to the Q? Is the 0 belongs to the Q? No, this is fine. This is a fine. But if I choose this example, fine, all these entries are my, what is the eigenvalues? Eigenvalues are my plus minus 1. So if I choose this number, then eigenvalues are my lambda square. Okay, fine. If I take 0 and 1, then no, just wait. If I choose because my target is to change 0 1 minus 1 0, A, B, C, D are in integer. What is the eigenvalues? Plus minus iota, and eigenvalues are not the part of Q. So yes, B option is the wrong option, because he said all those A, B, C, D in the Z such that eigenvalues are in the Q. But I have a one counter example that eigenvalues are my complex number, that's why it is not in the part of B. Okay, look at this one. The same question I already explained you in my rank or determinant or the system also. It's a 2 cross 2. Let's say it has a 2 eigenvalues. A. What is the determinant of the A? Lambda 1, lambda 2. What is the eigenvalue of the A plus I? 1 plus lambda 1, 1 plus lambda 2. What is the determinant of 1 plus I plus A? This number. So I can substitute this equation 1 plus, now you can open this bracket, 1 plus lambda 1 plus lambda 2 into this number. Now clearly say 1 will be cancelled out, so that means lambda 1 plus lambda 2 is my 0. Now look at that, this means product of them 0, that means this is the trace of the matrix is my 0 is the right answer. Okay, A, I can simply choose 2 cross 2 matrix such that A square minus 7A plus 12I is my 0. What does it mean? Trace of the matrix is 7, determinant of the matrix is this. So can you think about the matrix? 4, 3. Fine. This is my matrix 2 cross 2. A is invertible. Clearly say determinant is my non-zero, or you can say the rank of the matrix is the 2, which is the number of the column vector. Yes, this is my true. Small t is the trace of the matrix. The trace will be 7. So I can substitute this value 49 minus 49 plus 12 into n is my 2, which is my non-zero. So this option is cancelled. D is my determinant of the A, that is D is my 12. So if I substitute this number is a 144, 12 into 7 is 84 plus 12 is equal to 0, which is again not possible. Lambda is the eigenvalues of the A, so you can see the eigenvalues are my 3 and 4, and clearly it satisfied this equation. Otherwise this is my characteristics equation, and you can clearly say the eigenvalues equations are my satisfied. So A and D are my correct answer of this problem. Okay. A and B are my 2 cross 2 complex matrix, which are the following statement are true. Okay. A has eigenvalues lambda 1 and lambda 2. B has eigenvalues mu1 comma mu2. A plus B has eigenvalues lambda 1 plus mu1, lambda 2 plus mu2. Now first option, A plus B are invertible. Invertible means the determinants are non-zero, that means 0 is not eigenvalue. So that means each of the lambda i's are my non-zeros, each of the mu I are my non-zero. Then what is the eigenvalues of the A inverse plus B inverse? That means 1 of the lambda I plus 1 over mu I. So that means mu I plus over this number. Now since both the numbers are my non-zero, so this product will also be non-zero. So that means this is my invertible. Inverse, if you take as a negative, so what will happen? This number is my A inverse minus B inverse, that will be mu I minus of this number. Can it be 0? Yes. If you simply take lambda I is my 1, mu I is my 1, that's fine. That means if you simply take A is my this, or call as identity matrix, B is my this, clearly say A is invertible, B is invertible, sum of them is invertible, but if you calculate the A minus B, that is my 0, it is invertible, not invertible. Fine. Now AB, if AB is my nilpotent, AB is my nilpotent, that means eigenvalues of the AB are my 0, 0, if I consider 2 cross 2 matrix. Fine. Then AB is my nilpotent. How you can prove that BA is also nilpotent? So your targets to prove any power should be 0. If I prove this number, then it means it's a nilpotent. I can simply choose scale. Fine. So that I can written as BA, BA. What is this number? AB is my nilpotent, that means AB is my 0. Fine. So if this number will be 0, that will be my 0. So therefore BA is my nilpotent. Last option, characteristics polynomial of AB and BA are equal if A is invertible. How you can prove that characteristics polynomials are equal? If I prove that BA and AB are similar matrix, fine, then it means their characteristics polynomials are same. Now you can see that I can write this AB. How you can write this AB? Or I can start from the BA, for example. Can I write this number in this manner? Fine. I can write this number is AB into A. Why? Because A is invertible given. Now what does it means? BA is equal to invertible of this. What you conclude from this case? BA is similar to the AB. Once they are similar, characteristics polynomials are my same. Eigenvalues are also same. Minimal polynomial are also same. Trace is also same. Anyhow, they are talking about the characteristics polynomial. A, C, D are my right answer of this part. Okay, look at this another one. So matrix is not given to you. I consider the 2 cross 2. If A is my 2 cross 2 with integer entry, is a 2 cross 2, Aij is 0 when I is greater than j. So I is greater than j, this number, and I is my 1. What about this number? They are not given to you, so I consider this number is my A. Or you can think about any number, say 2. Fine, this is my matrix. Then A inverse exists and has integer entry. Same rule. If A has integer entries such that determinant of A is non-zero, what does it mean? A inverse exists. Fine. A inverse exists if and only if determinant of A is plus minus 1 and their entries are my integers. Now it is given that the diagonal entries is my 1. That means determinant is my plus minus 1. Therefore A inverse, that means AB is equal to I. Fine. That is a B is the inverse of the A. So A inverse exists and the entries are my integer. A inverse exists and some entries are not integer. That's the false statement. A inverse is a polynomial function of A with integer coefficients. That's true. You can write the characteristics equation. That's a lambda square minus 2 into lambda plus determinant. So you can see the coefficients. This is a 1. Coefficients are my integer. A inverse is not the power of A unless A is identity. I can say this example. What is the A inverse? Determinant is 1, so minus 2, 0. Clearly say this number is not be written as A raised to power something. So is not the power? Yes, it is also the right answer. So C and D are the correct answer of the problem. A is a 2 cross 2 non-zero matrix. A square is 0. A is my non-zero. That means A is my nilpotent matrix. Fine. Also it is given that A is my non-zero, and we all know that non-zero nilpotent matrix is never diagonal. Fine. Non-zero nilpotent matrix will never be a diagonal. So first one is a diagonal matrix. Wrong answer. If it is a non-zero, then it may be a diagonal, but non-zero can never be. A has 2 distinct eigenvalues. Is it true? No. You can consider any of the non-zero. Fine. This satisfied A square is equal to 0. It's a nilpotent matrix. But what are the eigenvalues? Eigenvalues are 0 and 0. They are not distinct, but he said distinct. Whenever there is a counter example of the nilpotent matrix, always consider this one. A has only one eigenvalue. A has only one eigenvalue with multiplicity 2. Yes, because it's a nilpotent matrix. Fine. A square is equal to 0. So what is the eigenvalue of the nilpotent matrix? Eigenvalues is always my 0, and and dimension is, that means how many times is a 2 times, so multiplicity, algebraic multiplicity is my always 2. AV is equal to V for some V which is the part of the C2. What is the meaning of that? It means 1 is the eigenvalue, but A square is equal to 0 is always nilpotent matrix, and the eigenvalue of the nilpotent are always 0 and 0 but not 1. So first D option is cancelled out. C is my right answer. Okay, again you can see n cube. This is my nilpotent matrix. It is given as a non-zero. It's a non-zero. So non-zero nilpotent matrix is not diagonalizable. The first is A is not similar. Correct option. A is similar to the diagonal matrix. Wrong option. Fine. Now, one A has one non-zero eigenvector matrix. Fine. What is the eigenvalues of this? Eigenvalues are my 0, 0. So definitely once you have the eigenvalue, so there exists an eigenvector. Fine. There exists eigenvector. So A has a one non-zero eigenvector. That's a correct option. A has 3 linearly independent eigenvector. What does it mean? Linearly independent eigenvector means geometric multiplicity. Eigenvalues are always 0. So your target is to prove this condition. This meaning geometric multiplicity of 0 is 3. That is not true, because if geometric multiplicity of the 0 is 3, from here you can also see algebraic multiplicity of the 0 is 3. What you conclude from these two cases? N is my diagonalizable matrix, but we already seen that N, that is a nilpotent matrix, is not diagonalizable. So it means this option is not true. Is the so right answers are A and C are the correct option. N is my non-zero 3 cross 3 matrix such that n square is my 0. Again you can see N is my nilpotent matrix. Fine. Also it is given that they are my non-zero. So once it's a non-zero, it means it is not diagonal. Fine. So A is not similar to the diagonal matrix. Correct. A is similar to the diagonal matrix. Cancel out. Because eigenvalues of the nilpotent matrix are 0 and 0. Fine. So once there exists eigenvalue, definitely there exists the eigenvector which has a non-zero corresponding to the eigenvalues lambda is equal to 0. So yes, A has one non-zero eigenvector. Why? You can see if I simply choose this and eigenvalues are 0, fine, A square is my 0, n square is my 0, definitely the eigenvectors you can easily obtain. What does it mean? Linearly independent eigenvector, that means geometric multiplicity of the eigenvalue is my 3. Again it is not possible because algebraic multiplicity of the 0 is my 3. It means n is my diagonalizable, which is not possible. So this option is also cancelled. A and C are my right answer of this problem. Okay, look at this another one. Again I can choose n is my 2 cross 2 with the real entries. A is my 2 cross 2 has the real entries. If A square is 0, then A is diagonalizable over complex number. A is no, that's no. If I simply choose this number, fine. What does it mean? A square is my 0. What is the eigenvalues of this matrix? Or you can say right here, what is the eigenvalues of this matrix? 0 and 0. Algebraic multiplicity of the 0 is 2. Can you find the geometric multiplicity? That means 2 minus rank of this matrix. So rank of this matrix is my 1. So clearly say which is not equal to the algebraic multiplicity. That means it is not diagonal. So that means this option is cancelled. A square is equal to I. What is the meaning of the A square is equal to I? That means this is involutory matrix, and we all know involutory matrix is Diagonalizable over R and C both. Fine. A is diagonalizable over the real, that's fine. A square is equal to A. This matrix is called as projection matrix. Fine. Or this matrix is also called as idempotence matrix. And this matrix is again diagonalizable over both R and C. He said he is diagonalizable only on the complex number. That's a rule. The only matrix of the size n, I consider n is my 2, the only matrix of the size 2 satisfying the characteristics polynomial is A. The only matrix means, that means they are talking about the uniqueness. So can you think about the two matrix A and B such that the characteristics polynomial of A, characteristics polynomial of B are same? If this condition hold, that means A is not unique. Fine. If A is not unique, that means this option will be cancelled out. So can you think about that? I think very simple. I can think this one. Clearly say A is not equal to B, but the characteristics polynomial of B are my same. So therefore this option is also cancelled. Only B is my correct answer of this problem. A is my 4 cross 4 invertible matrix. Determinant is a non-zero. Rank of the matrix is number of the column vector. Fine. Which of the following is not necessary true? The row of the A form the basis of R raised to power 4. That means rank of the A is my 4. Yes, that's a correct statement, but we need a false statement. Null space contain the 0 element. So if rank is 4, what is the nullity? Number of the columns minus rank. Nullity will be my 0. That's also the correct statement. A has 4 distinct eigenvalues. Distinct, that is not true. If I simply choose A is equal to I, 4 cross 4 matrix, fine, is an invertible matrix. What are the eigenvalues of the A? They are not distinct, but he said distinct. This is my false statement. Image of the linear transformation AX on R4. Now because rank of the A is my 4, that means determinant is my non-zero, that means it is my 1 1. So definitely the image of this transformation is my R4. So this is my true statement. The only correct answer is C is my correct answer. Okay, look at this another one. A is my 4 cross 4 such that rank of the A is my 2. Fine. So that means you have the 4 eigenvalue. One eigenvalue must be 0. Fine. One eigenvalue must be 0 because the rank is less than of 4. A cube is equal to A square, non-zero. A is not diagonal. That means algebraic multiplicity is not equal to the geometric multiplicity. Now my target is to find the 3 eigenvalues. A cube is equal to A square. That means if you find the minimal polynomial, what will happen? The minimal polynomial is x cube minus x square is 0. Or if you write in terms of the eigenvalue, then lambda cube minus lambda square is 0. That means fine. Now how you can find the minimal polynomial corresponding to this? That will divide them. So factors are lambda, either the lambda square, either this number or this number. Fine. Now rank is my 2. If rank is my 2 and A square is my non-zero, so this definitely be not true. Fine. This is my linear factor. Fine. If the minimal polynomial has a linear factor, then it is a diagonalizable, but it is given that it is not diagonalizable, so this option is also cancelled. This is a linear factor, this option cancel, this option cancel. So that means this is the only possible minimal polynomial of the matrix A. Fine. Now once you know this is the minimal polynomial, so what I can write here is minimal polynomial is lambda square into lambda minus 1. Then based on this minimal polynomial, can you define the Jordan block? What is the Jordan block corresponding to this eigenvalue? I can write this number is lambda minus 0 square, lambda minus 0 1. So that means there is a block, at least one block of the order 2 corresponding to the eigenvalue this, fine, and there exists at least one block corresponding to the eigenvalue 1 of order 1. So you can see one of the Jordan block is my this number. Yes, it's a correct statement. A square is equal to A. Is it true? No, because if A square is equal to A true, then it will be A into A minus 1 0. That means you can see this is my linear factor. So if this is my linear factor, it means the matrix is my Diagonalizable, but it is given that not Diagonalizable. There exists a matrix, there exists a vector V such that AV is my non-zero, A square V is my 0. So A is my 4 cross 4. Fine. First of all, I need a square 0. So I can think about this will give you the A square 0. Fine. Now I need A as a non-zero. That means I must put up diagonal entries somewhere as a 1. Fine. The rest elements I can consider as a 0. So clearly say A is my non-zero. Fine. And I can choose any of the vector V. What I can choose the vector, because the second position, so I can choose the second position as a 1. So clearly say AV is my non-zero. If you multiply them, the second element will be 1. What is my A square? If you find the A square, it will be 0 0. Last element will be 1 only. The last element will be 1. And if you multiply this by this vector, it is basically a 2 cross 2. Fine. Then A square V will be 0. So there exists a vector. Yes, there exists a vector. The last option is the characteristics polynomial is x cube into x minus 1. Okay, this is the target. Is it the characteristics polynomial? You can see the minimal polynomial I have obtained is x into x minus 1. So that means one eigenvalue is 1, x square, so second eigenvalue is also 0. Now, what is the third eigenvalue? What will be the third eigenvalue? Okay, if the third eigenvalue is my 0, first of all rank is 2, definitely this eigenvalue is my non-zero. Fine. So if this, it means this eigenvalue is my 1, because if the minimal polynomial is my this, then the characteristics polynomial may be either this one is a 0 or this one is my 1. Fine. But this can never be possible, because if this number is my 0, then the rank will be 1. That is not possible. It means the minimal polynomial, this means this is my characteristics polynomial. But he said x4 minus x cube. This is not the x4 minus x. Fine. It's a very simple. I can clear the last option for you again. As we know, these are the 4 eigenvalues. Rank is my 2. I can obtain 0 and 1 are my eigenvalue. Since this is my minimal polynomial, so that means you can see the algebraic multiplicity is 1. 0 has 2 multiplicity. Now that eigenvalue either the 0 or that eigenvalue either the 1. It can never be 2, because 2 is not the factor in the minimal polynomial. Fine. Now what will happen if this number is my 0? Then what will be the rank? These are my eigenvalues. How many non-zero eigenvalues? 1. Fine. So that means, what does it mean? Rank will be less than of the 2, but we need a rank is 2. That means this number can never be 0. So if this number can never be 0, that means this eigenvalue will be 1. So up to this part, what is the minimal polynomial is x square into x minus 1, and this part is my x minus 1. So what will be the minimal, what is the characteristics polynomial? X square into x minus 1. So this option is cancelled. A and C are the right answer of this problem. Look at this another one. Which of the following matrix have Jordan canonical form equal? If I call this is my A, options are my B, then our target is to check this number. Fine. What is your target? You have to firstly check rank of the A and rank of the B must be same. What is the rank of this matrix? 1. So this has a 1, fine. This has a 1, fine. This has a 1, this has a 2. So this option is cancelled. Fine. Because Jordan blocks, if Jordan canonical forms are same, then their rank must also be same. Now, second one. Out of these three, what is this? Is my, that means 0. This is the nilpotent matrix. Fine. This is also the nilpotent matrix. This is also the nilpotent. This is also the nilpotent matrix. So that means which of the following is same? This is a nilpotent. Fine. This is also the fine. This is also the fine. So A, B, C are the right answer of this problem. Otherwise, you can find the minimal polynomials of the matrix A and of the options that must be same. Otherwise, there is no need. You can simply check about the nilpotency occurring. Okay, I consider this is my 2 cross 2 matrix. Fine. A and B are my 2 cross 2 matrix over the complex number C. Then AB and BA always has the same set of the eigenvalue. That's true. That's a straightforward result. AB and BA have the same set of the eigenvalues, then AB is equal to BA same. That's not true. Fine. If I simply choose say 2, okay, I can choose again the lower triangular matrix, say 3. Fine. What is the AB? If you multiply them and if you multiply by BA, clearly say both are not equal. So that means this option is cancelled out. But they have the same eigenvalues. Why? Because you can see the diagonal entries are 1. Fine. This is 1. You can see AB has eigenvalue 1 and 1. BA has eigenvalue 1 and 1. But AB is not equal to B because this values is my different. You can see if I multiply them 1, 2, 0, 1, 1, 0, 3, 1. So what will happen if you multiply them? 1, 3 plus 2, 5, 1 and 1. This is my 5. Now if you multiply B into A, 1, 2, 0, 1. So it will be 1, 2 plus 3. That's it's again 5. No, that's the same. That's the same value. So can you think about any other example? AB and BA are not same. Which example you can think? If I choose, this is my minus 1, A is my minus 1, so then it will be my minus 1, it is my minus 1, fine. Then it will be my 3, 2 minus 3 minus 1. Yes, this is that. If I simply take is a minus 1, B, this is my minus 1, this is my plus 1. So this number will be 1, 3 plus 2, 5, 0 and minus 1. Fine. And if I take B into A, 1, 2 minus 3 is a minus 1, 0, 0 and minus 1. Yes, you can see eigenvalues are, this is a minus 1. Eigenvalues are same, but the matrix are not same. If A inverse exists, then AB and BA are similar. That's the same part. If A inverse exists, I can write this number is A inverse into A. Fine. So I can see this number I can return like this. So BA is equal to inverse of this. BA is similar to the AB. Yes, this option is the correct. The rank of AB is always same of the BA. That's not true. We very simple example. always consider this example. Fine. And I can choose B is 1 0 0. Then what is my A into B? If you multiply them, A into B and B into A. So what is that? I can count the B into A. B into A. So this number will be 0 1 0 0. What is the AB? 0 1 0 0 1 0 0 0. So that will be 0 0 0 0. Clearly say the rank are not same. So the right answers are A and C are the correct answers. A is my 3 cross 3 matrix which are the following real entries. A is necessary diagonal. A is with the real entries. No. A is necessary. Can you provide the example? Non-zero. You can simply choose as a non-zero nilpotent matrix. Fine. 0 0. Fine. Clearly say it is not diagonal. Okay, look at this. A has the distinct eigenvalues, real eigenvalue, then it's a diagonal. Yes, correct. A has the distinct eigenvalue, then it is diagonal over C also. If all the eigenvalues of the A are non-zero, then it is diagonal over C. That's not true. You can are non-zero. I can simply choose this matrix. Fine. Then algebraic multiplicity of the eigenvalue 1 is 3. Can you find the geometric multiplicity? 3 minus rank of A minus eigenvalue 1 into I. So what will happen if you calculate 3 minus A minus lambda I? 0 1 1 0 0 0. What is the rank of this matrix? 2. 3 minus 1 is 3 minus 2 is 1, which is not equal to the algebraic multiplicity. So it is not that. So the right answers are B and C are the right answers. Same example you can think about for this first part. A is necessary diagonalizable over R, but this is not diagonal. A is my matrix 3 such that A raised to power 8 is my I. So A is my 3 cross 3 such that this, then the minimal polynomial of this. Any matrix is satisfied. Identity. What is the minimal polynomial of this? X minus 1. What is the degree of this minimal polynomial? 1. Can only wrong. Only wrong. A is equal to I. A is equal to minus I. Is it true? No. Because you can see what is the eigenvalue of the A raised to power 8. Lambda raised to power 8, where lambda is the eigenvalue of the A. So that means if I choose lambda is minus 1, then it is plus 1. If I choose is a plus 1, then again it's a plus 1. So that means if I choose eigenvalues are my this matrix. Fine. So A has eigenvalue 1 minus 1. What is the eigenvalue of the A raised to power 8? That is the identity matrix. So but this is not I or not minus I. So this option is also cancelled. The right option, which is the left behind, is the right answer. How? You can see I can choose the diagonal entries 1. Fine. Now there exists uncountably many. How you can provide the one example for the uncountably many? I can choose any A, where A is my fine. Eigenvalues are my 1. A raised to power 8 is my 1 always. So whatever the value of A, you can choose 1, 1 by 4, any number that will be give you uncountable. So the right answer is D is my right answer. A is my n cross m complex matrix. A is my self-adjoint. B is the inverse of A plus iota. B is the inverse of this matrix. Then the eigenvalues of. So it means my target is to find the eigenvalues of the A I we know that, and eigenvalues of the B. Fine. What is the meaning of that? A is my complex matrix, A is my self-adjoint. What does it mean? A is my Hermitian matrix. Fine. Once we know that A is Hermitian matrix, then the eigenvalues are always greater than equal to 0 real. Fine. This is given to you. Then can you find the eigenvalues of the B? Because it's a inverse, 1 over lambda plus I is the eigenvalues of the B. Fine. And eigenvalues of the B are occurring in the pairs because it's a complex number. Then the eigenvalues of the B are these numbers. So if you rationalize them, it's a lambda minus I over lambda square plus 1. It is lambda plus I over lambda square plus 1. Purely imaginary. Is it true? Purely imaginary? No. Why? Because you can choose. Why is not a purely imaginary? Yes, because if I choose lambda is my 1 which satisfies this property, then it is not a purely imaginary. Of modulus 1. Of modulus 1. So that means this number. Fine. Yes, is it true? How you can say it's eigenvalues of, no, this is the eigenvalue of B. I need eigenvalues of this. Sorry, first option we can't say right now. I need to find the eigenvalues of this component. So what is the eigenvalue of this? Lambda minus I into eigenvalues of the B. So B has eigenvalue 1 plus, fine. Second is this into 1 over, so that is a 1. Fine. This is, now look at that. If this is a complex number, assume that this is a complex number, then definitely the complex number occur in the pair, but this is not in the pair. This is a real number, so that means this must be, no, that is not, because it's a modulus. Okay, it's a purely imaginary number. That's true because it's 1 also. Modulus less than 1, that's wrong because we get a 1 number also. Is it a real or modulus 1? So firstly we can check about this modulus. So this is a 1. Is it true or not? Now we can't say this number will be, so lambda square plus 1 minus 2 iota lambda over lambda square plus 1. Fine. Now what will happen? What is the answer of this case is it a real? No, because you can see for every non-zero lambda it must have a complex number also. Is it a real? No, it's also a cancel out. So now it's a modulus 1. But how you can say it's a modulus 1? How? So only the one option is left, but how you can say that this value is my 1? So that because the 3 options I have discarded, so this value, it means it must be the 1. Fine. Okay, M is my, given that 1 is it's a 3 cross 3, so you need a 3 eigenvalues. One eigenvalue is my 1. Can you find the other eigenvalue? Look at the sum row. Is a 1? No. Sum is not same. Column 1, column 1, column 1. So that's 1 is eigenvalue given to you. Okay. The one way is you can compute the other eigenvalue, but there is no need. If this is the minimal polynomial, this is the minimal polynomial, definitely whatever the minimal power is given to you, what does it mean? 1 is the eigenvalue, minus 4 is also the eigenvalue. Fine. So I know the 2 eigenvalue. The third eigenvalue I can compute it from the diagonal sum. That is my this. Clear? Now out of these 3 cases, which one is the minimal polynomial? Which one is the minimal polynomial? So okay, diagonalizable and so on. Algebraic multiplicity of the 1 is 2. I can find the geometric multiplicity of the 1. 3 minus rank of a minus lambda I. 0 minus 1, 2, 0, 4, minus 2, 1, minus 5. Fine. Can you find the rank of this? I can add them. It's a 0, 1, minus 1. I can add them first and the last column, then it's a 0, then it's a 0. So the rank of this will be 2. 3 minus 1 is 3 minus 2 is my 1. So algebraic multiplicity is not equal to the geometric multiplicity. That means this matrix is not diagonal. So this option is cancelled out. If this is not diagonalizable, then definitely the factors are not linear, because if this is the because these are my linear factor, if this option is the correct, then it means this is my diagonalizable. So but it is not, cancel. This is the correct option. Now look at this last option. First of all, what is the degree of this? If I open them, I can written this is 4 is m square plus 3m. Clearly say the degree is my 2, but what is the minimal polynomial degree? Minimal polynomial degree is my 3, is not divisible. So that option is also cancelled. So therefore this option is B is my only right. There is one more way. Can you factorize them? You can see I can written m square plus 4m minus 4 is 0. So that means m plus 4, m minus 1 is 0. You can see again they are my linear factor, but because m is not diagonalizable, so it has not linear form. So this option is also cancelled. B is the right answer. Okay, again you have the 3 eigenvalues. One eigenvalue is given as a 1. Again you can check about the row sum and the column sum. Minus 1, minus 2. So row sum will not be same. Look about the column sum. 2, again 2, again 2. So that means 2 is one of the eigenvalue. Fine. Remember, each column sum is my 2. That means 2 is the one of the eigenvalue. Now you know the 2 eigenvalues. Can you find the third eigenvalue? By the trace. Trace is my 5. So the third eigenvalue is my 2. Minus 2 is the eigenvalue cross. 3 is the eigenvalue cross. M is diagonalizable. So I can see algebraic multiplicity is my 2. What is the geometric multiplicity? It's a 3 cross 3. 3 minus rank of A minus 2i. So can you find the rank of, can you find the A minus 2i? Minus 2, minus 1, 0, 1, 0, minus 1, 1, 1, 1. Now clearly say, if I add R2 plus R3 and then subtract, and if I add them simply, what will happen? 0, 0, 0. That means the rank will be less than of, so that means it's a 1, so which is not equal to the algebraic multiplicity. That means it is not diagonal. So this option is cancelled. Eigenspace has, eigenspace means that is a geometric multiplicity of each eigenvalue has dimension 1. Clearly say the 1 has only one eigenvalue, so it has geometric multiplicity 1. What is the geometric multiplicity of the 2? I have computed as a 1. So that means C is my right answer of this problem. 7. N is an odd number which is greater than or equal to 7. I can choose N is my 7. A, so that means it's my 7 cross 7. Fine. With a 7 cross 7 matrix, A, I plus 1 is equal to 1 for all i's, and A n comma 1 is my 1. A n comma 1, that means 7 comma 1 is my 1. Rest values are my 0. Okay. Aij is 0 for all the other pairs. Now if I choose I is equal to 1, so 1 comma 2. Fine. 1, 2, 3, 4, 5, 6, 7. 2. So 0, 0, 1, 0, 0, 0. Similarly for third pair, it is my 1, rest are 0. fourth, then fifth pair, and the last pair is sixth pair, and this one is 7. Fine, this is my 7 cross 7. Now what does it mean? Each row, so first of all, each row sum is my 1, so therefore 1 is the eigenvalue. So yes, first option is the correct one. Column sum is again 1. No, the last one is 1, 2, 3, 4, 5, 6, 7. Last one is, no, column sum is not 1. Row sum is my 1, so 1 is eigenvalue. Okay, minus 1, A has no real eigenvalue, that's wrong, because I got 1 as the eigenvalue. This option is cancelled. A has at least one eigenvalue with multiplicity greater than 2. Now, how you can find that? Clearly say, this is the diagonal matrix 0, and above diagonal matrix is my 1. So that means this is my companion matrix. Fine. So once it's a companion matrix, can you write the characteristics equation? This is lambda raised to power 7 minus, start from here, this 0, then 5, then 4, then 3, then 2, then and then finally constant. Fine. Make sure if the 1 1 appears below the diagonal entries, then you have to look about this column. If the companion matrix written in the above that diagonal, then you have to return the last row. Then it means your companion matrix will be this one. So that means, now clearly say which is of the odd degree. So one real root must be there. So no real root, that option, that also be discarded from here. Minus 1, is it minus 1 satisfied? No. So minus 1 is also the wrong option. Has at least one eigenvalue with multiplicity greater than 2. That's wrong option, because it is my odd degree. Now if you look about this number, then it is 6, 5, fine. Then all those rest of the roots are my complex number, and complex number occurs in the pair. So there is no root of multiplicity greater than or equal to 2. So that means all are my simple roots. Right answer is A is my correct. Okay, look at this another one. Which of the following are my eigenvalues of the matrix? So how many rows are there? 6 cross 6, iota minus iota and so on. You can see this is my 0, this is my this number. So I can write this matrix basically 0, I, 0. Fine. So what are the eigenvalues? I already told you many times, if it's a 0, it's a A, it's a B, it's a 0, then how you can find the eigenvalues? It's a plus minus product of these off diagonals, A, B. So in this case, plus minus I. So that means plus minus 1 or minus 1. Plus 1, minus 1. So that is A and B are the right answers. If omega is the complex root of the unity such that omega cube is 1, but omega is not 1, then A is given to be 1 omega omega square, omega omega square, omega this 1 and 1. Then A is invertible, rank of the A is 2 and so on. Now clearly say, if you add, now what is they have the 3 eigenvalues. What is the row sum? Row sum is 1 plus omega square. 1 plus omega square is 0. That means one eigenvalue must be 0. Column sum is also same. Make sure if the row sum is 1 plus omega square, column sum is also 1 plus omega plus omega square, it doesn't mean that they have the two eigenvalues of 1 plus omega square. Fine. Now 0 is the one eigenvalue. What does the meaning of that? Determinant will be 0. So A is invertible. Wrong. Is the rank 2? What is the meaning of the rank 2? That means we need a 1 2 cross 2 minus whose determinant will be non-zero. So omega square minus omega 0, omega square minus omega 4. Omega 4 will be my omega. That's a non-zero. Clearly say this is a minor we have obtained which is non-zero. Yes, rank will be 2. That means these two eigenvalues are my non-zeros. 0 is one of the eigenvalue. Yes, fine. There exists linearly independent eigenvector such that AB, this is 0. What is the meaning of AB is equal to 0? I can return this number is my here. That means 0 is the eigenvalue. Remember AX is equal to lambda x. X is my eigenvector. Lambda is my eigenvalue. So 0 is the eigenvalue. We prove that. What is the meaning of that? 0 there exists. Yes, that option is also the correct option. Okay, A is a 3 cross 3 with a real end twist such that the determinant is 6. Then which of the following is the eigenvalue of A? Check about the determinant 6. No. Fine. It's not true. It's not fine. Trace will be 0. You can see that. Trace is a non-zero. Trace is a 0 is the right answer. There is no need of this. Fine. Otherwise, if you want to check, so A has the eigenvalues lambda 1, lambda 2 and lambda 3. What is the eigenvalues of the I plus A? This number. Fine. Determinant is a 0. So if you add them, look at that. My answer is this. If I add them 1, it will be 0. Minus 1, 2. Again, you can see that determinant is a 0. Otherwise, based on these two properties, I can easily discard the options. Don't forget to like and comment on my video. A is my 5 cross 5 such that characteristics polynomial of the A is same as characteristics polynomial of the A inverse. Many times, as I told you, whenever there is a question related to the matrix, you always start from the I is these three examples. Fine. Always consider these three examples to discard the options. Let's firstly, I can simply choose A is equal to identity. Because if you choose 0, then A inverse does not exist. So that means 0 is not possible. If A is equal to I, what is the A inverse? Again I, that means characteristics polynomial of A, characteristics polynomial of the A inverse is also same. That will be lambda minus 1 raised to power 5. Then which of the following is my satisfied? What is the A square? Is I. What is the trace of the A square? Is 5 cross 5. 5. What is the A square trace is 5, but he said 1. Trace of A raised to power 5. A raised to power 5 is also I. What is the trace of A raised to power 5? 5. Cancel. What is the determinant of A square? 1. May be correct. A raised to power 5, 1, which may be correct. Now this example over. Now look about the A is equal to minus I. I need the determinant. If A is equal to minus I, A inverse is also minus I. Fine. Then again the characteristics equation are same. What is the A square? A square is my I. Determinant of A square is again 1. But what is the A raised to power 5? It is my minus I. So determinant of A raised to power minus 5 is minus 1. But he said plus 1. So the right answer is A is my correct answer. Okay, P is my characteristics polynomial of the 2 cross 2. So we know if A is my matrix, how you can write the characteristics equation? Trace of the matrix plus determinant of the matrix, such that P of A, characteristics equation of the P, characteristics of the P inverse is my constant. Fine. That means if I write the characteristics equation of A, that means lambda square minus trace of the A plus this. What is the characteristics equation of the P A inverse is? Trace of the A inverse plus determinant of the A inverse is 0 when it will be constant. When it will, if you subtract them, when it will be constant, when only this term will be same, then only it will be cancelled out. That means trace of the A inverse are same. That's the only condition, because once they are same it will be cancelled out. Determinant of A is a constant, A inverse is a constant. Now what is the meaning of that? So if either this is my A, either you can find the trace, find the inverse, otherwise you can see if lambda 1 lambda 2 are the two eigenvalues, what is the eigenvalue of the A inverse. Now if you simplify this, if you take the LCM, clearly say this number will be 1. What does the meaning of that? That means product of the eigenvalue means determinant should be 1. So 12 minus 6 not 1, 12 minus 6 not 1, 9 minus 8 1, correct option. 8 minus 9 minus 1, wrong option. C is the correct answer of the problem. A and B are my okay, first of all I consider 2 cross 2. So that means determinant of A is non-zero, determinant of B is my non-zero. So 0 is not eigenvalue. Again it's an invertible, so that means rank of the A is my 2, number of the columns, rank of B is also my 2, such that AB is diagonal with eigenvalues this number lambda 1 lambda 2, because I consider 2 cross 2 matrix. Which of the following is not correct? Okay, which of the following is my not correct? I think very simple. There is no need to, because clearly say AB is diagonalizable and A inverse exists. So what is the meaning of that? I can write the BA as A inverse AB into A. Fine. What is the meaning of that? BA is similar to the AB. Fine. What does it means? If both are similar, that means eigenvalues are same. It means trace of them are same, determinant of them are same, characteristics polynomial are same, eigenvalues are same, and so on. So eigenvalues of the BA is the same eigenvalues of the AB. Correct option. But we need a false statement. Fine, this is my correct. If AB is my diagonalizable, then BA is also diagonalizable. If AB is my invertible, A and B are invertible, so that means this is also my invertible. So that means BA is equal to AB is not always correct. So that means the C is my right answer of this problem. You can provide the one counter example also, there is no issue, but that's a simple argument. Once you prove that's a similar, that means BA is equal to BA is not always true, but they have the same example. If you remember in previous example I have taken, this is my 2, B is my 0, 1, 0, say 3. Clearly say both have the eigenvalues same. A is invertible, B is invertible, but AB is not equal to BA. A is my 3 cross 3 matrix such that omega cube is my 1. Then the first option is A cube is equal to I. Then the eigenvalues of the A are 1 omega omega square. Wrong. If I simply choose A is equal to identity, it satisfies this property. What are the eigenvalues? 1, 1, 1. So this option is false. If A cube is equal to I, then every eigenvalues of the A lies in the set. Yes, if it's a 1, then again it lies. Otherwise, if they are in the complex, then it's a 1 omega omega square. If the eigenvalues of the A are 1 omega and omega square, then A cube is I. Is it true? I don't think so. It's a very simple. I can assume eigenvalues are my 1 omega omega square. Fine. I can simply choose this number. Can you say A cube is equal to I? No. Fine. So this option is also cancel. Now, if every eigenvalues lies in the set of this 1 omega omega square, then can you say about a cube is I? If every eigenvalues of the a, again the same example, whatever the eigenvalues lies in this set, but a cube is not equal to I, so this option is also cancelled. So I think the B is my right answer of this problem. Let A is my 2 cross 2 matrix such that set of all those eigenvalues which are my non-zero has exactly R elements. That means cardinality of the S is my R. Which of the following statement is my correct? Okay. Simply choose first element, matrix this. Fine. A is my 2 cross 2. What are the eigenvalues? 1 and 0. What is the set S? Collection of all those non-zero eigenvalue 1. What is the cardinality? 1. Fine. What is the rank of this matrix? 1. 1 is less than equal to 1 satisfied. Okay, 1 is less than equal to 1 satisfied. In this case, rank is 1 is greater than equal to 1 satisfied. R is 0. Okay, I have to change the example. I can choose this matrix. A is equal to I. Fine. What are the eigenvalues? 1 and 1. What is the set? Consists of all those non-zero eigenvalues. Cardinality is 1. What is the rank of this matrix? 2. Clearly say 2 is not be less than equal to 1. 2 is greater than equal to 1 satisfied. A square has R distinct value. What is the A square is again I. A square. What is the A square is I. Then has R distinct. R is my 1. Yes, it's satisfied. But whenever it's a distinct, I can consider this. Then what is the S? Eigenvalues are 1 and minus 1. R is my cardinality of this set is my 2. What is my A square? 1 0 1 0. Then how many elements in this A square? A square has 2 distinct non-zero eigenvalue, but it has only 1 eigenvalue. It is not equal to R. If R is equal to 0, I can take the one example of R0. So that means R0, that means I can choose nilpotent matrix. I can choose any matrix, say 0 1 0 0. Then eigenvalues are my 0 and 0. So S will be my empty, cardinality will be 0. Then if R is equal to 0, what is the rank of this matrix? Rank of this matrix will be my 1. But clearly say 1 is less than of n minus 1. Not possible. So the only left option is C is my right answer. Okay. A is my say 2 cross 2 matrix such that C is equal to this. C is A, B, C and A, B, B and A. Then which of the following is my correct option? First of all, you can see that what is the row sum? Row sum is A plus B. So definitely A plus B is one of the eigenvalues of the C. So lambda is the eigenvalue. If lambda is the eigenvalue of the A plus B, then lambda is the eigenvalue of C. Correct option. Can you find the other eigenvalues? The sum will be 2A, trace will be 2A. So the other eigenvalue will be A minus B. So if lambda is the eigenvalue of A minus B, lambda is also the eigenvalue of C. If lambda is the eigenvalue of A or B, if lambda is the eigenvalue of A or B, lambda is also the eigenvalues of the C. You can simply choose. You can simply choose the one example whose row sum is not same. Fine. Or look at that. All the eigenvalues are my real. Can you think about any example whose eigenvalues are not real? This. What is the characteristics equation? Lambda square plus 1. Clearly say lambda is my plus minus iota. Complex number option. if lambda is the eigenvalues of the A or B, if lambda is the eigenvalues of the A or B, then lambda is the eigenvalues of the C. How you can prove that lambda is the eigenvalue of A or B? Then okay, that's wrong. Why? Because these are the eigenvalues of the C. Fine. If lambda is the eigenvalue of the A or B, only or, fine, that means one of the eigenvalue is my A or only B. That's the meaning of this. But C has eigenvalue only A plus B and A minus B. It is C does not have eigenvalue. What is the meaning of this part? That means C has eigenvalues lambda. Where is the lambda is the eigenvalue of only A or B? That's wrong, because C has eigenvalue A plus B and A minus B. So that option is also wrong. A and B are my right answer of this problem. Okay. V is R cube is any non-zero vector. I can choose any non-zero vector. Say simplest one is this number. Define a linear transformation X. So X will be my X, Y, Z, such that X, Y, Z minus X dot V. If X is my X, Y, Z, X dot V will be my X divided by V dot V is my 1 into 1, 0, 0. So can you solve them? It is my X, Y, Z. It will be my 2x 0 0. So that will be my minus x y z. So can you define the matrix? This is my matrix corresponding to this transformation. Now look at that. Once you know the matrix, then eigenvalues are, what is the eigenvalue? 1 and minus 1. Fine. Determinant is minus 1. Fine. Trace is plus 1. Is a distance preserving. What is the meaning of that? Tx minus ty must be equal to the x minus y. Clearly say, because it's a diagonal matrix. Fine, it's a triangular matrix, so definitely the distance will be preserved. So the right answers are all are my correct options. Okay, A is my 100 cross 100. It's a very big number. Fine. Such that I plus Aij is my I if I plus j is my 101. So if I consider this number, so this number will be my I, 1. If I consider 2, then it will be my 99 is I. That means this is the kind. Fine. Rest values are my 0. Now once you know the matrix, is it, you can see that it's a diagonal matrix, but it's the opposite sign. But we will see how you can find the eigenvalues. So firstly I will give you the tip. If A is my like of A, B, C, D, rest all values are my 0. Fine. Then how you can find the eigenvalues? It is plus minus first number, last number. Fine. Comma. Plus minus second number, second last number, B, C, and so on. Fine. If it is my even numbers. Now as I told you, if it is a 0, it's a A and B. What is the eigenvalues? First number, last number. Now what is the eigenvalues of this? Plus minus 100 first number, last root this. Plus minus 99 into 2, plus minus and so on. So clearly say each numbers are my distinct. Fine. Each eigenvalues are my distinct. If each eigenvalues are my distinct, that means this is my Diagonalizable matrix. Yes, it is my diagonal. One of the eigenvalues is my 10. So row sum we can't compute, but you can see that this value will give you the plus 10. None of the real eigenvalue exceeds 50. You can see the eigenvalues are my plus minus 10. This number will be my 198. Fine. So what will be the square root of this? It will be around 20, no, 15, 16, 17. Fine. That means it's a less than of the 20. Similarly, next number will be 98 into 3. Fine. So what is the meaning of that? Can you find exceeds the 51? The eigenvalue will be 51 square. So can you find the square of the 51? 525. So that means 2601. Can you find the two product? Oh, okay, one more thing that comes directly in my mind. Otherwise, you can clearly see the product. None of the eigenvalue is my greater than of the 50. Because why? Because there is a middle number about 50 and something. So that means 50 into something. For example, say 49. Fine. That number will be always less than of the 50. So none of the eigenvalue exceeds 51. That also the correct option. But there is one more option that you may understand. Let me clear this one. Have you you learn in your numerical analysis, that is the bounds on the eigenvalue. Fine. That is called as the Brammer bounds. So how you can find that? This value will be less than of sum of the elements apart from the diagonals, minimum among them. So what is the sum of the elements apart from the diagonal? 1, comma, column 100. So the minimum is 1. Similarly, for the second, it's my 2, then 99, and so on. The last number will be less than of 50. So clearly say the upper bound of this eigenvalue will be less than equal to 50. So that means that none of the eigenvalues less than 50 is the correct option. A, C, D are my right answers. Okay, this is again m square is equal to m. That is called as this matrix is called as idempotent matrix, but m is not my I and 0. So basically this matrix is the projection matrix. Fine. So what is the property of this? That means what is the eigenvalues of this? Eigenvalues are my 0 and 1. Fine. So these are the two eigenvalues which are my distinct eigenvalues. So they are corresponding the one eigenvector corresponding to the nullity. One eigenvector, this is a non-zero corresponding to the columns. Fine. So first of all, this option, and they are my disjoints. Fine. Why disjoint? Because m is not my 0 and 1. If m is 0 and 1, then this may or may not be disjoint. But in this case, this is a disjoint. So what does the meaning of that? That means I can say this is my direct sum. So direct sum means that's a column is my rank vector space dimension. If x belongs to my column dimensions, x is my non-zero, then x is the eigenvector corresponding to the eigenvalue 1. Correct. Nullity corresponding to the eigenvalue 0. Correct. X does not belongs to the 0. Then x is the eigenvector corresponding to the eigenvalue 1. That is not true because of this disjoint. So this option is also cancelled. A, B and D are the right answer. This option is maybe correct if m is either the 0 or I. But if x does not belong to the this, it doesn't mean that it belongs to the column. M A is my 3 cross 3 nilpotent matrix. Then I plus A. Okay, A is my nilpotent matrix. I consider this matrix. This is my nilpotent. Fine. For some n, I can choose n is 1. Clearly say this is not equal to the I. So first option is wrong. Column space of the A is my 0. That's wrong. Column space is my 1, 0, 0. Eigenvalues of A are the roots of the 1. That's wrong because what is the eigenvalues of the nilpotent matrix? 0, 0 and 0. This option is cancelled. A cube. A cube is my identity. This matrix is my Diagonalizable matrix. Identity is Diagonalizable matrix. So this is also my, no, A cube is my 0 and 0 is my Diagonalizable. So that means A cube is also my Diagonalizable matrix. Moreover, you can find this. Also you can see algebraic multiplicity of these numbers and the others. Okay, find the trace of the A plus B. Trace of A, trace of B. What is the trace of A? -1. Trace of B. Find the eigenvalues of the B. When it is a minus 1, it is 1. When it is plus 1, 5 plus 1, again plus 1. When it is 1, again plus 1. When it is minus 2, 16, minus 20, plus 5, 1. So trace is 4, eigenvalue is 3 is the right answer. A has 3 cross 3 matrix. It may be the real, it may be the complex. Which of the following statement is my false? A must have the, that's fine. If A is my 3 cross 3, that means the characteristics polynomial is of third degree, fine, which is my odd. So once it's an odd degree, it means there exists at least one real root, and that real root is my eigenvalue. So it has one real root, have a real root, fine. If determinant is 0, then 0 is the eigenvalue. That's obvious, the correct statement. It has the 3 eigenvalues. If determinant is strictly less than 0, one eigenvalue is my 3. Other eigenvalues we never know. So that eigenvalues may be the real or the complex. Assume that it is my complex. Then complex number always occur in the pair. Fine. Then what is the condition for this? What is the determinant of this? 3 into alpha square plus beta square. It is always greater than 0, but we need a less than 0. So that means 3 is the eigenvalue. Then A has complex number can never be true. That means all these eigenvalues are my real eigenvalues. That's also the correct statement. Fine. But we need a false statement, so these 3 options are cancelled out. Last option is the correct. How? Again, you have the 3 eigenvalues. 1, 3 is the eigenvalue, either the real or the complex. Then A has 3 eigenvalues. But if I assume it is my complex number, what is the determinant of this? It also satisfied. Fine. But he said A has a 3 real eigenvalue, but complex may also be possible. So this option is false. So that means the right answer is D is my correct answer. This is my 2 cross 2. A raised to power, rank of A raised to power 4 is my 0. That means A raised to power 4 is 0. That means A is my nilpotent matrix. Fine. Which of the following statement is equivalent to this statement? A has n linearly independent vectors. That means we are talking about the Diagonalizable matrix. That means A is my Diagonalizable and A is my nilpotent. So we all know this if and only if A is my 0 matrix. This is the result as I explained you. If A is my Diagonalizable and nilpotent matrix, if and only if A is my 0 matrix. So B is my right answer. Okay, n is my greater than equal to 3. I can choose is a 3 cross 3. Then that same question I have explained many times. Aij is the product of ij. So 1 1, 1 into 2, 1 into 3, 2 into 1, 2 into 2, 2 into 3, 3, 6, 9. Then eigenvalue. Check about the row sum. 6, not same, not same. Column sum, not same. Fine. Now clearly say, if I use, because you can see R2 minus 2R1, 0. R3 minus 3R1, again 0. So that means determinant of the matrix is 0. One eigenvalue is my 0. What is the rank of this matrix? 1. So that means 2 eigenvalues are my 0. Can you find the third eigenvalue? That is the trace. So trace will be 14. So which one of the following? 1 is not possible. N is my 3. 3 is not possible. When you substitute 3 into 4 over 2, that is a 6. Not possible. Only left option is my last option. So it's a 6 plus 1, 7 over 6. 6, 2 is 12, 14. So that's a 4, D is my right answer. I can choose n is my 4 cross 4 with a complex entry. Which of the following statement is my correct? A does not has a invariant subspace, all the eigenvalues are real, invariant subspace. Firstly, think about this. All the eigenvalues are my real. It is my 4 cross 4. It's a even number. Fine. So if I choose one eigenvalue is this, eigenvalues always occur in the pair. So this is my minus iota. What are the eigenvalues? These are my eigenvalues. Fine. All the eigenvalues are real. Cancel. Fine. Now, the next three options are my related to the invariant. What is the property of the invariant? If you consider any of the vector space V, you consider the subset of the W, first of all. Fine. Then this is said to be the invariant. How you can prove that? If you have the transformation T, fine. If you multiply this matrix with the subset, it must be the part of this W. Fine. If you prove this condition, that is implies related to the invariant. Can you find that transformation? Because it's a 4 cross 4, so my transformation is R4 to R4. Can you take any of the subset of, because it's a matrix? Fine. Can you subset of this matrix? I can take as a identity. Fine. T is basically my matrix A. So now, what is my TW? TW is basically my A, W. A is my A, W is my I. So clearly say A is the TW, AW. Okay, yes, fine. So, okay. Sorry, I think I taken as a wrong. If I choose matrix as my identity, fine. Matrix is my identity. So that means T is equal to my identity. So what will happen? W is the subset of W. It satisfied. Fine. But he said does not. Wrong. Does not. A square. If I take A is equal to I, what is my A square? Again I, again satisfied. This option cancel. Only left option is my B is my right answer. A is my n cross n matrix. I can say 2 cross 2. Real symmetric matrix. Eigenvalues are my real. Fine. It may be greater than 0. It may be less than 0. Or it may be 0. But it must be the real. Then all the eigenvalues are real. Satisfied. A is diagonalizable. That's true because every real symmetric matrix is my diagonal. If A raised to power k for some positive k, choose k is equal to 1. If A is equal to identity, A square is also identity. Fine. Again for this, if A is equal to 0, that means A square is also 0. So that means this option is also correct. So all these options are my right. So this is the way you can solve all these eigenvalues related problem. I hope you can like, comment and share this video with your friends. We will see the next lecture on the lecture series on the complex analysis if I get the good response to this video. Till then, you can share this video with your friends. Best of luck students. Happy learning.